Welcome to Python for Scientific Computing 1. In today's video, we'll look at branching statements. Branching statements are also called conditional statements, and they are part of the procedural-oriented programming paradigm. As their name suggests, what branching statements or conditional statements do is they evaluate one or more conditions, and if those conditions were to be met, it will execute a set of commands. Alternatively, if that conditions are not met or some other conditions are met, then another set of instructions are executed. So this allows us to incorporate decision making into our programs, and as such, branching statements provide versatile tools for us that are very beneficial for scientific computing. So in today's video, let's take a look at the branching statements that are available to us through Python. So before we delve into our lecture, let's recap what we have done so far. We started off this video series by studying why we want to study programming and in particular Python for scientific computing. We looked at various data types that are available to us in Python, as well as data structures to deal with sequences of data in Python. I then introduced you to Google Colab and Jupyter Notebooks. Google Colab is a software as a service platform that we use to implement Python on the cloud. One advantage of Google Colab is that it uses Jupyter Notebooks as its interactive development environment. And Jupyter Notebooks allows us not only to run Python, but also intersperse it with HTML and LaTeX to create interactive notebooks. We used Google Colab and Jupyter Notebooks to solve some simple expressions. And in the process, I introduced you to some common syntax, such as putting comment lines using hash, using print statement, as well as performing addition, multiplication, subtraction, division, and raising something to a power. I also discussed the order of mathematical operations in Python, which is very similar to what you have learned in mathematics. So all this is what I group as module 1 or the basic building blocks. Our module 2 gives you another set of building blocks, and those building blocks focus on decision making and iteration in Pythons. In today's lecture, we'll look at conditional statements. We'll follow this with looping, which are for loop, while loop, iterators, and then also introduce you to some additional syntax associated with these statements. Python, as you know, is an interpreted language. Interpreted language essentially means that the code is executed from the top to the bottom, line by line. Of course, doing calculations line by line can sometimes be problematic because we want to do non-sequential calculations. For example, we might want to do one set of calculations based on one or more conditions and perform some other calculations when those conditions are not met. Similarly, we might want to do the same calculations on all elements of a list or a tuple before moving forward. In other words, we want to go back and forth and loop through the entire list or tuple before we move forward. There are also cases where we want to keep doing some calculations or a set of calculations till some condition is met. We don't know when this condition will be met, so we can't know for sure how many times we have to iterate before that condition is met. So all these are non-sequential calculations, and Python provides us with functionality to do this conditional and repetitive calculations. The if statement and its variants are used for conditional-based branching, and the for and while loops are used for iterative calculations. So conditional and repetitive calculations are part of what we call the procedural-oriented programming paradigm. And the development of this procedural-oriented programming paradigm back in the late 50s all the way through 70s was what helped with the development of algorithms for scientific computing. So when we write procedural-oriented programming, what we really want to do is we want to first evaluate a statement, and if that statement were to be valid or were to be true, we want to go and execute a set of commands. And then once that evaluation statement proves to be false, then we move further down to other statements that are below it. Okay. So a code block is how Python defines what are the statements to be executed for a given evaluation statement. Okay. Many languages use curly brackets or some other form of way to group your code. And what's unique about Python is that Python uses indentation to group code that is to be provided as part of that evaluation statement. And this is called a code block. You will come to see code blocks with every procedural-oriented programming commands such as if-else, for, while, loop, and all the other variants that are available in Python. And I want you to notice in particular the syntax or the structure of the code block. The code block always has an evaluation statement. It is followed by a colon. The colon tells us that the code block or the beginning of the code block, and everything in that code block is indented. And then the other statements, which are not part of this evaluation statements, are in line with the initial evaluation statement. Okay, so it has three elements: an evaluation statement that is tested to see whether it's true or false. Then we have a colon. The colon ends the evaluation statement or signals the beginning of the code block. Then we have a set of code block statements that are indented, and then the indentation is removed and other statements follow. Right? So for branching statements, the if statement is perhaps the most fundamental of all branching statements. What it does is it tests an expression, and if the expression is true, the code block or the body of if is executed. And this body of if is executed only once, and then it proceeds downwards to the statement just below it. If the condition is false, then this body of if is neglected and the code automatically moves to the statement just below it. So for example, I have x is equal to 2. This is just I'm defining or assigning a value of 2 to x. And then I'm going to write my evaluation statement. My evaluation statement here is if, and I say if x is less than 3, notice the colon, and then notice the indentation. I'm saying x plus equal to 2. This is the same as writing x is equal to x plus 2. Since my value of x is equal to 2 at the beginning of this code block, what it does is it takes 2, adds 2 to it, which is 4, and places it in the new value of x. And then what I want to do here inside the code block, because of this indentation, is I want to say print the initial value is less than 3, and then I'm coming out of that code block and printing the value of x is x. Okay. If I were to run this code with x is equal to 2, it goes and checks if x is less than 3. As that is the case, it goes in and performs these two calculations. It updates the value of x to 4. It also prints this statement onto the console, which it has done here, comes out of the loop, and then writes the value of x to be equal to 4. On the other hand, if I were to initialize this x to be equal to 5, and what it does is it comes to this if statement and then checks if x is less than 3. It is not the case. So it skips these two lines and goes outside that loop and then or outside that if statement, and then it prints the value of x is equal to 5. If the condition is true, the code block of if is executed. If the condition is false, the code block associated with the if is not executed, and the line immediately below that if code block gets executed, and the program moves downwards. Okay. Again, Python uses indentation. So you're seeing if, which is the evaluation statement, if x is less than 3, followed by a colon, and then there are indentations. One good thing about writing code using Jupyter Notebook is that these indentations are taken care for you automatically. The minute you put a colon, Jupyter Notebooks understands that there is a code block coming, and it will create whatever is necessary there for it to happen. Okay, that is true for other compilers as well. The if-else statement is a variant of if, and what happens here is that you start as usual, you evaluate the condition. If the condition is true, the code block associated with if is executed, and the program proceeds to the next step. If the condition is false, then the body of else, or the code block associated with else, is executed, and then the program continues. Okay. So for example, I could write if x is less than 3, I want to say x is equal to x plus 2, and write the initial value is less than 3. Else, what I want to do is I want to add 3. I want to say x is equal to x plus 3, and then print the value of x is greater than or equal to 3. And notice that this print statement is in line with if and else. So once one of these are executed, the program will move to the print. The new value of x is this. Since I have initialized the x to be equal to 2, the if part is true. And because the if part is true, it'll take the value of 2, add 2 to it, and print the value as 4. It entirely skips this else because this has proven to be correct. On the other hand, if I were to initialize my x is equal to 5, the if block is not true. So it skips this if block, goes to the else block, takes my 5, adds 3 to it. The new value is printed as 8. It also prints this statement, which is part of the else block, saying the initial value of x is greater than or equal to 3. Okay? So this is how you write if and else statements. Of course, you can put if statements within if statements and else statements, and you can create more complex branching. This type of branching is called nesting. Python also provides you with another tool called if-elif-else statement. And what if-elif-else does is it allows you to put multiple conditions using elif, and then the last condition is written as else. Again, to look at an example, we say that if x is less than 3, I will add 2, and I will print x is less than 3. If x is greater than or equal to 3 and x is less than 6, which means 3, 4, and 5, or some decimal versions of it before it hits 6, I'm going to add 3, and I'm going to whatever my initial value of x is, and I'm going to print this value that x is in the range of 3 to 6. 3 is inclusive, 6 is exclusive. If none of these are true, then I'm going to add 5 to x, and then I'm going to write that the initial value of x is greater than or equal to 6, and then notice I come out of this conditional statements and print the new value of x. So when I have 2, the first condition is met, so I'm adding 2 plus 2, so the new value is 4. It is also printing this in the loop saying that the initial value is less than 3. Similarly, if my x were to be initialized to 5, then clearly the if statement is not valid. It is greater than 3 and less than 6, so the elif statement gets triggered, And since this is true, it'll add 3 to 5 and gives me a value of 8. And it also prints what's in here. Similarly, if I were to put x is equal to 10, neither the if or the elif will be valid. So it'll go straight to else, add 5. It added 10 plus 5 gave me 15, and it also printed the initial value is greater than or equal to 6. Notice here I only show one elif, but you could have multiple elifs, as many elifs as you need, and the last statement is put as else. So if-else, and if-elif-else are the three basic syntax that has been with Python since its inception. There is a new conditional statement case called the match, which has been recently added to Python since version 3.10 plus. What it does is there is a text that is matched, and then once the text is matched, you perform a set of operations. For example, I have 3 inputs here. X is equal to 2, Y is equal to 10, and I'm calling another variable here called operation, which I'm putting it equal to plus. Now look at this match code block. What it says is match the operation, and if the case is plus, then my result is x plus y. So it is taking this plus, so it takes 2 plus 10 and gives me 12, which is what it's doing here. If the case were to be minus, it will do x minus y. If the case was, if I give my operation to be multiplication, or that star sign in quotes, then it'll give me x times y. And if it were division, it would give me x divided by y. If I gave something that is not plus, minus, multiplication, or division, then I have this case underscore. And what this underscore basically writes it is, if none of these are valid, then it goes here and says invalid operation. And it basically prints that invalid operation. Okay. So in this case, since since I'm giving my operation to be plus, it is giving me result equal to 12. If I had given division, it'll give me a value equal to 0.2 because it's 2 divided by 10. Keep in mind that the case must exactly match. The operation here must exactly match the case. If it doesn't, then the last case, which is this underscore case, will be evaluated. So in summary, branching allows us to create a set of instructions based on the condition. So when the condition is met, one set of instructions are carried out, otherwise another set is carried out. The if statement is the primary syntax for branching. There are variants of if, which are if-else and if-elif-else. Okay. You can also do nesting of if necessary. The code gets complicated and hard to follow. So if possible, try and use if-elif-else in such situations. The match case statement can also be used for nesting. However, the case that must be matched for the condition to be executed, whereas with if, you can have greater than or less than, whereas in match case, it has to exactly match. So these are some of the choices we have when it comes to branching in Python. Understanding branching, particularly using if and else statements, is critical as part of your learning. So I hope you found this video useful. In the next video, I will talk about some additional statements that are part of the procedural oriented programming paradigm. Till then, take care and stay safe. Goodbye.